Today, we are discussing the topics Introduction to Planning, Reasoning in Uncertain Situation, Logic based Abductive Inference. Our first topic is Introduction to Planning. Planning. What is planning? Planning means it involves a sequence of actions which helps to reach a desired state or goal from the initial state. So, for reaching this goal, we will have to utilize the resources, certain constraints, and the environment's dynamics. We know that we have to reach a certain goal, so it becomes goal oriented. That is, there will be a series of actions that transform the current state to the final state or the desired state. We have to search the space of these possible actions which help to reach a goal, a certain goal. So, a best sequence of actions should be determined from these actions. For finding this best sequence of goals or best sequence of actions, we will have to represent the problem domain, which should include initial state, final state, goals, the actions that we have to perform, and the effect of these actions. So for that, we can use state space representations, action graphs, planning graphs, etc. What are the importance of planning? Planning have goal achievement, problem solving, resource optimization, adaptability as the important factors. Goal achievement means we know that we have to reach a certain goal for which we are planning from the initial state to the desired state. It will have a sequence of actions. Problem solving, that is, there will be many complex problems involved for finding the solutions. So these complex problems can be broken down into manageable steps. So it reduces its complexity. Next one is resource optimization. If we are having an effective planning or if we utilize an effective planning, it will maximize the utilization of the available resources and reduces the wastage. Next one is adaptability. We know that plans can be adjusted, so it is an important factor of planning that it can be changed based on the environment and the new information, which makes it more flexible, and it helps to find out the desired sequence of actions which reaches the desired state or the goal state. Planning a problem. For planning a problem, we have to find the sequence of actions which can achieve the goal, which when executed from the initial state reaches the final state. That is, it will consist of a set of operator descriptions. These operator descriptions will define the primitive actions that is done by the agent. Then it will consist of an initial state description and a final goal state description. It helps to compute a plan or formulate a plan which consists of a sequence of operator instances that after that by which after executing them we will reach from the initial state to the goal state. We know that there are several actions involved in reaching the desired state or the goal state. So all these actions will have sub goals. So these sub goals will be taken and the conjunction of these goals will reach the final goal. So the conjunction of the goal is achieved for reaching the desired state or the goal state. Planning versus problem solving. Planning and problem solving actually often solve the same sort of problems itself. Planning is somewhat more powerful and efficient because it can be represented, and there are several methods used for representing. We have discussed it earlier. States, goals, actions will be decomposed into set of sentences. Then the search will proceed over the planned space rather than state space. Also, the subgoals can be planned independently. Each subgoals there will be certain actions which help to reach the desired goal state. So these sub-goals can be also planned independently. This reduces the complexity of the problem, the planning problem. Our next topic is reasoning in uncertain situation. For that we have to understand about the uncertainty. What is uncertainty? Uncertainty means if for some reasons we will have incomplete knowledge about the environment, about an environment or about a problem, that is including unreliable sensor data or the unpredictability of a system, etc. So these situations may reach in an uncertainty. We have several techniques that can handle this uncertain situation. First one is probabilistic reasoning, which include probability theory. That is, it involves mathematical probability theory, which help to reason the uncertain situations. That are that means the events, there will be several events in the problem, and these events will be assigned with the probabilities, which help to quantify and reason the uncertainty. Next one is probabilistic graphical models, that is a Bayesian network, etc., which help to represent this uncertain situation. Uh, that is, Bayesian networks are graphical models that represent the probabilistic relationship among the variables. Bayesian inference actually help to update our beliefs that we will have certain hypotheses regarding the initial conditions, initial the data we have, observed data we have. So we can update those hypotheses and beliefs based on the new evidence, which helps to become more useful in these uncertain environments. One of the important technique is fuzzy logic. Fuzzy logic mainly deals with reasoning which is more approximate than being more precise, because it utilizes the representation of the imprecise information, which include membership functions, linguistic variables, etc. Some of the key factors of fuzzy logic include degrees of truth, that is, it operates with the help of degree of truth, which include, that is, there will be several elements in this fuzzy set. So it represents the extent to which these elements belong to the particular set. It is represented by the degree of truth. Fuzzy set will have several membership functions. These membership functions describe how the element belongs to a fuzzy set, how the element of the universe belongs to the fuzzy set. That is, there will be specific condition or property for an element to belong to a set, a particular set. So to which degree an element satisfies the specific condition, it is defined by this membership function. Also, fuzzy rules and inferences are used. Fuzzy logic mainly uses the linguistic rules, fuzzy if then rules, and the fuzzy logic operators such as and or not for combining the inputs and generating the output, fuzzy output. Fuzzy logic operators including fuzzy set, fuzzy and, fuzzy or, also the operations involving union, intersection, complement are used for processing the fuzzy information and making the decision. It is one of the important methods involved. We can have a look at a problem, that is, question, is it hot outside? So if we are using a fuzzy logic for finding the solution, then we will have the solution that certain solutions, that is very hot, it may be very hot, little hot, moderately hot, or not hot, and it have certain values too. Here fuzzy, we can see that it is very well clear that fuzzy logic is using a wider range of output for getting the solution, such as very hot, moderately hot, and not hot, and the most appropriate solution will be selected from these one. So the values are here ranging from 0 to 1. If it is a Boolean logic utilized for finding the solution, then we will only have two values, 0 and 1. That is, it is hot or not hot. But while using fuzzy logic, we are having a wider range of output. It is one of the best features of fuzzy logic. Next topic is logic based abductive inference. For that we have to know about abductive reasoning. Abductive reasoning majorly focus on generating a best explanation or a hypothesis from the observed data or evidence. That is, it infers the explanation that best fit the observed data. Logic based abduction means it applies formal logic to perform abductive reasoning. That is, logical rules will be utilized to generate the hypothesis from the observed evidence. That is, we will have certain observed evidence, data, etc., and from that we will apply some certain logical rules and find out a hypothesis that best fit the observed data. So in artificial intelligence, certain rules are used and then we evaluate these explanations. For example, if we are having an implication, cricket ground is wet if it is raining, so we will take the axiom cricket ground is wet. Then we, from the implication, we will reach to a conclusion that it is raining outside because the ground is wet. So some of the process involving in this abductive inference is observation. Initially we will observe the certain facts that are provided, which is required for the explanation, for formulating the explanation. Then hypothesis generated. There will be multiple hypotheses generated, and from which we have to take the best one. There will be multiple hypotheses and explanation according the observed data. Evaluation. We previously said that we use certain logical rules for evaluating. So from these multiple hypotheses, from the which is evaluated based on a criteria, we will evaluate the best one with the observation simplicity, explanatory power, and the coherence with the existing knowledge. Selection. That is the major step which select the best fitting hypothesis from this explanation for the observed data. And the main thing that is to be noted that in abductive reasoning, it doesn't guarantee any of the correctness of the explanation. It just aims to find the best explanation from the available information. It doesn't guarantee the correctness, that it doesn't guarantee that it is a correct explanation. It only finds the best explanation from the available information. So these are the topics covered in this session. Thank you.